Let us solve for x in this exponential problem. X squared minus x raised to power 3 is equal to 150. What I will do is first transfer 150 to the left hand side. So if I transfer 150 to the left hand side, the equation now becomes x squared minus x raised to power 3 minus 150 is equal to 0. 150 itself can be expressed as 125 plus 25. But because there's a negative here, this will simply mean we can break down 150 to negative 125, then minus 25. I'll replace negative 150 here with negative 125 minus 25. X squared minus x raised to power 3 minus 125 minus 25 is equal to 0. Also, 125 can be expressed as 5 raised to power 3, and 25 can be expressed as 5 raised to power 2. So let us replace 125 and 25 with 5 raised to power 3 and 5 raised to power 2 respectively. So this gives us x squared minus x raised to power 3 minus 5 raised to power 3 minus 5 squared is equal to 0. So I have x squared here and 5 squared here. I have x raised to power 3 and 5 raised to power 3 here. Let me bring x squared and 5 squared together, and these two are already together. So rearranging the equation, I'm going to have x squared minus 5 squared, then minus x raised to power 3 minus 5 raised to power 3 is equal to 0. This way I can group these two and then group these two. So I have x squared minus 5 squared minus then x raised to power 3. This will then be plus because the negative is outside of this newly introduced bracket, then plus 5 raised to power 3 is equal to 0. We can see that the first one is a difference of 2 squares and the second one is a sum of 2 cubes. For difference of 2 squares, if you have a squared minus b squared, we can express this in factorized form as a minus b and then times a plus b. So I can go ahead and replace x squared minus 5 squared with x minus 5 x plus 5. But before I do that, let's find an expression for sum of 2 cubes. This is a known identity. If you have a cube plus b cube, you can also express this as a plus b into brackets a squared minus ab then plus b cube b squared rather. So it means x cubed plus 5 cubed will now be replaced with x plus 5 into bracket x squared minus 5x plus 5 squared. So let's go ahead and individually substitute this. So for x squared minus 5 squared, I'm replacing with something that looks like this, which will now be x minus 5 x plus 5, then minus So this will be minus. So we are replacing this bracket with something that looks like this. That's going to be minus. I'm going to put that here, x plus 5 into brackets. So this will be x squared minus 5x then plus 5 squared. Let's tidy this up because of this 5 squared. So I have the first one remains the same, x minus 5, x plus 5, then minus x plus 5 into brackets, x squared minus 5x plus 25, and then the result is equal to 0. The reason I've written this under this is because I want us to see that there's a common term in the first term and the second term. So in this product, x plus 5 is common to this product, x plus 5. So bringing these two together, I didn't cancel them out, I'm just highlighting it so you see that we have common terms. So I'm going to write x plus 5 into brackets. What's left here is x minus 5. Then what's left here will be, this is minus, don't forget the brackets, then x squared minus 5x plus 25, and the result is equal to 0. So let's tidy up these inner brackets by opening up the brackets. So we have x plus 5 into brackets. So this is x. X minus 5x here will give us plus 6x. So I have 6x. Then minus 5 minus positive 25 as minus 5 minus 25, that's minus 30, and then finally minus x squared is equal to 0. So from here we can then say this implies that x plus 5 is equal to 0, which means that x here is equal to negative 5, and then it also means that 6x minus 30 minus x squared is equal to 0. This is a quadratic equation, and if we rearrange it, we get x squared minus 6x plus 30 is equal to 0. Is this factorizable? Looking at this quadratic equation closely, we see that it is not factorizable. We would have to use the general quadratic formula, and in this case we need to identify the coefficients of each term of the expressions on the left. So x squared, the coefficient of x squared, let's say is a, is going to be 1, and the coefficient of x is negative 6, and then the constant times c is 30. So we can then apply the general quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac, then divided by 2a. If we put in these values, then x is going to be minus b. b is negative 6, so we have negative 6 plus or minus the square root of negative 6 minus a is 1 and c is 30, so that's negative 4 into 1 into 30. Then divided by 2 into a is 1. X is equal to 6 plus or minus, there's a square here, negative 6 squared is 36, so we have the square root of 36 minus 4 times 1 times 30 is 120, then divided by 2a. 2 times 1 is 2. So here x is 6 plus or minus the square root of 36 minus 120 is negative 84, then divided by 2. Then x will be 6 plus or minus, if you use sort to break this down, you will get 84 is 4 times 21, so that's 2 roots negative 21 divided by 2. We can divide here. Our final answer for this part will be x equal to 3 plus or minus the square root of negative 21, which is an imaginary solution, and we can also express it as x is equal to 3 plus or minus root 21i. So there are two values here. We already got x earlier to be, let's call that x1 to be negative 5. If we split this into two different solutions, then x2 will be 3 plus root 21i, and then x3 will be 3 minus root 21i. So because the last two solutions are imaginary solutions, there's not much we can do with them. So our approach solution will be x is equal to minus 5. And to check that x is equal to minus 5 is the correct solution, we will need to insert it back into the question or the problem and see that the equation is balanced on both sides. So the equation or the problem is x squared minus x cubed is equal to 150, and our solution is x is equal to negative 5. So we're going to put negative 5 in place of x in this problem, and it should give us 150. This implies we now have negative 5 squared minus negative 5 raised to power 3. Negative 5 squared is 25. Then minus negative 5 raised to power 3 is negative 125. This is 25 plus 125. And of course, 25 plus 125 is simply 150, which is equal to where we started from, and the equation is balanced. Therefore, x is equal to minus 5 is the solution to this problem. Thank you so much for watching. Hit that like button, subscribe to my channel, and I'll see you in my next video.